So we need to find the interval of convergence of the given series. We will use the ratio test here. So we need to find L, limit of the absolute value of an plus 1 over an, where n approaches infinity. So it equals the limit of the absolute value. An plus 1 equals 4 to the power of n plus 1 times x minus 1 to the power of n plus 1 over n plus 1. And this whole thing is divided by an, but we can just multiply it by the reverse of an. So basically n over 4 to the power of n times x minus 1 to the power of n. And n approaches infinity. Let's simplify this. This equals limit of the absolute value of 4 times x minus 1 times n over n plus 1. And n approaches infinity. Then this equals 4 times the absolute value of x minus 1 times the limit of the absolute value of n over n plus 1, where n approaches infinity. Then it equals 4 times the absolute value of x minus 1 times the limit of the absolute value of 1 over 1 plus 1 over n, where n approaches infinity. Well, now since n approaches infinity, then 1 over n approaches 0. So this limit approaches 1. So we get that this equals 4 times the absolute value of x minus 1. And now we know that for our function to be, for our series to be convergent, this has to be less than 1. Then 4 times the absolute value of x minus 1 is less than 1. Then the absolute value of x minus 1 is less than 1 over 4. Then x minus 1 lies between negative 1/4 and 1/4. Then x lies between 3/4 and 5/4. So this is the interval of convergence of the given series.